Hello, 6th grade. Today we are going to move on to Unit 3, which is over expressions, equations, and inequalities. So starting today, we're going to do Lesson 15, which is talking about numerical expressions with exponents. So, numerical expressions. If you look at the word numerical, numerical means numbers. So, when we are looking at these expressions, we're going to be talking about expressions with numbers. But what are expressions? Well, basically, expressions are just problems. They are the problems that you work out. So, if we're talking about numerical expressions, we're talking about problems with numbers, such as this here. So, let's go ahead and move on. Now, I know mine looks a little different than yours, but all the questions should be the same. If something comes up different, then we'll work with that as we go. So, the question on the first page says, a sports store orders a box of table tennis balls. The dimensions of the box are 10 inches by 10 inches by 10 inches. Inside the box, there are 6 layers of table tennis balls. Each layer is made up of 6 rows and 6 columns of table tennis balls. How many table tennis balls are in the box? So let's use the math we know to work out this problem. The first one says, write a multiplication expression to represent the volume of the box. Well, we know when we're finding volume, it's length times width times height. So in this case, we would be doing 10 times 10 times 10. Now it says write the expression you wrote for the volume of the box using exponents. So when we do that, the number that we're multiplying, which in this case is a 10, becomes the big number in your exponent. So the big number would be 10. Then how many tens you're multiplying becomes your exponent. So you have 1, 2, 3 tens, so you put an exponent of 3. So it would be 10 to the third. Write a multiplication expression to represent the number of table tennis balls in one layer of the box. Well, it says that there are 6 layers of table tennis balls, and there are 6 rows and 6 columns. So for one layer, you would have 6 rows and 6 columns, so it would be 6 times 6. Then it says write a multiplication expression to represent the number of table tennis balls in all 6 layers. Well, you would have 6 times 6 and then times your 6 layers, so it would be 6 times 6 times 6. So then it says write an expression using the exponents to represent the total number of table tennis balls in the box. Well, just like we did up in the first one with the 10 times 10 times 10, we're going to do the same thing here. So the number we're multiplying is 6, so that's your big number. The number of 6s, there are 1, 2, 3 of them, so it's 6 to the third. Explain how you could find the number of table tennis balls in the box. Well, when we are doing 6 to the third, it is equal to 6 times 6 times 6, so we just multiply it out. So 6 times 6 equals 36, and then 36 times 6 would give us the total. So on the next page it says you already know that multiplication is the shorter way to write repeated addition. You use exponents to write repeated multiplication in a shorter way. So whenever we do repeated addition, such as 5 plus 5 plus 5 plus 5, a shorter way to do that is to multiply 5 times 4. When we're doing repeated multiplication, that's where our exponents come in. So if we have 5 times 5 times 5 times 5, it would be written 5 to the 4th power. The number you're multiplying is your big number. How many times you're multiplying it is your small number. Numbers raised to the 2nd or 3rd power are often read in specific ways. 5 to the 2nd power is read 5 squared. 5 to the 3rd power is read 5 cubed. We've done this several times as we've gone through the year so far, so hopefully that's more of a review for you. Expressions written with exponents are called exponential expressions. They're expression problems. The number being multiplied by itself is called the base, that's your big number, and then the exponent shows how many times you multiply the base by itself. So in this case, 5 to the third, 5 is the base, 3 is the exponent. 5 is the big number, that tells you what number is being multiplied. The 3 is the small number that tells you how many times the 5 is being multiplied by itself. The base of an exponential expression can be any kind of number. So you can see 7 squared would be 7 times 7. You can also do the same thing with fractions. So if you see 1/3 to the 5th power, you're doing 1/3 times 1/3 times 1/3 times 1/3 times 1/3. And you can do the same thing with decimals. If you see 2/10 written as a decimal raised to the 3rd power, you're going to multiply 2/10 times 2/10 times 2/10. When you multiply measurements with units, the units are also multiplied. So when we're talking area and volume, that's where you get for area inches squared and for volume inches cubed, because you're doing inches times inches times inches. That would be inches cubed. This is why area is measured in square units and why volume is measured in cubic units. So let's reflect. Number 1 says, is 2 to the 7th equal to 2 times 7? And then explain. So if we think about this, 2 to the 7th is equal to 2 times 2 times 2 times 2 times 2 times 2 times 2, which equals 128. 2 times 7 2 times 7 is equal to 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, which is equal to 14. So no, they are not equal. So the next page says, Julie's brother says that instead of paying her the $40 he owes her, he will give her $2 today and double the amount she has each day for 6 days. Should Julie accept her brother's offer? Why or why not? So we can model it using a table, so where you find the amount Julie has each day and then double it to find the amount she has the next day. So on day 1 she'd start with the $2. Day 2 it would be 2 times 2, which would be 4. Day 3, take the previous day, 4 times 2 is 8. Day 4, take the previous day, 8 times 2 is 16. Day 5, 16 times 2 is 32. And day 6, 32 times 2 is 64. Or you can do the same thing and set it up just in a little bit of a different way. Instead of working out each one from the previous day, you just add multiplying another 2. So day 1 would be 2, day 2 is 2 times 2, day 3, 2 times 2 times 2, and so on. So now let's go through and answer some questions about those. Number 2 says, look at the first model on the previous page. Why do you double 8 to find the amount of money Julie will have on day 4? So we would say because her total on day 3 was $8. So you multiply $8 by 2 to double it. Number 3, look at the second model it. How can you tell that the amount from the previous day is being doubled? Well, when you double something, or double a number in this case, you multiply by 2. Number 4, in the second model it. Okay, sorry about that. In the second model it, which expression represents the amount of money Julie will have on day 6? Well, if we're continuing our pattern, it would be 2 times 2 times 2 times 2 times 2 times 2. So we'd have 6 2s. Now, number 5, how can you write an expression for the amount of money Julie has on day 6 using exponents? Well, our big number is going to be the number being multiplied, which is 2. And we have 6 2s, so our exponent would be 6. So it would be 2 to the 6th power. How much money will Julie have on day 6? Should she take her brother's offer? And then explain. Well, if we multiply out 2 times 2 times 2 times 2 times 2 times 2, we get $64. So, should we take that? Yes, she should, because she gets more money than he owes. Number 7, Matt thinks that if Julie starts with $2, she will have $12 after 6 days. Explain what Matt is doing wrong. Well, Matt's looking at it as adding. He is adding. He is doing 2 plus 2 plus 2 plus 2 plus 2 plus 2. And that equals $14 instead of his total. Okay, so now you try. Use what you just learned to solve these problems. Show your work on here. You don't have to do a separate piece of paper. Once you're done, resume the video and check your answers. Alright, so let's look at number 8. Maria is buying a new carpet for her bedroom. Her bedroom is in the shape of a square and the length of each side is 12 feet. Write and simplify an exponential expression to find out how much carpet she needs. So we know area is finding our length times our width. So if we look at this, we know the length is 12 feet and our width is 12 feet. So we would do 12 times 12 or 12 to the second power, or 12 squared. 12 times 12 or 12 squared gives us 144 feet squared. Number 9, write and simplify a multiplication expression to represent 5 to the 4th power. Well, 5 is the number we're multiplying, and the 4 tells us we're multiplying it by itself 4 times. So it would look like this. Oops, sorry, that's a 5. And then when we multiply 5 times 5, we get 25. 25 times 5 is 125, and 125 times 5 is 625. Okay, so Michael, Morgan, and Keegan are in the same class. The teacher asked the students to write and simplify the expression 6 plus 4 cubed. Here are the expressions each person wrote. Which student will get the correct answer? Which, if any, of the expressions are equivalent? And then explain. So, here's where we're going to bring in order of operations. Use the order of operations to simplify Michael's expression. So on the first one, if we follow order of operations, we do the parenthesis first, 6 plus 4 equals 10, and then we would raise 10 to the 3rd power. So 10 times 10 times 10, which equals 1,000. On the second one, we are following order of operations. We have exponents, so we have to do the exponents first. So 6 cubed would be 216, and 4 cubed would be 64, and then we add those two together. 216 plus 64 gives us 280. Then the last one, we would do our exponent first. 4 cubed is 64, and then we add 6, so 64 plus 6 gives us 70. So now let's answer some questions. Number 10 says, look at Michael's expression. Why do you add 6 plus 4 first? Parenthesis. Whoops, back it up. Sorry about that. Parentheses come first. Number 11, look at Morgan's expression. Why do you simplify each exponential expression first? In this case, and this one, order of operations, no parentheses. So, exponents come next. Number 12, the teacher says the expression equals 70. Which student wrote the expression correctly? That means that Keegan wrote the expression correctly. Number 13, how might the teacher have said the expression if she wanted the students to write Michael's expression? she could have said the sum of 6 and 4 cubed. Because then that means you find the sum of 6 and 4 first, then you cube it. Number 14, Corwin tries to evaluate 4 squared times 5 plus 6 as shown below. So he does 4 squared times 11 and then 16 times 11 to get 176. Explain why this answer is incorrect. Well, he didn't follow order of operations. In order of operations, looking at this problem, before he added, he should have done the exponent. So, he should have done the exponent, then multiply, then add. So now try it down at the bottom. I want you to follow order of operations and evaluate 6 squared divided by 3, and then evaluate 3 plus 5 squared times 4. Once you're done, resume the video to check your answers. Okay, so if we're working on number 15, so we have 6 squared divided by 3. So, order of operations, there's no parentheses, do your exponent. So 6 squared is 6 times 6, so we get 36, and then divided by 3. So now we do our division, 36 divided by 3 gives us 12. On number 16, 3 plus 5 squared times 4. So we do our exponents first. So we would do 5 times 5, which is 25. So we have 3 plus 25 times 4. Next would be multiplication. So we do 25 times 4. And 25 times 4 gives us 100. So then we have 3 plus 100. And that gives us 103. Now, once you are finished with this, you can go ahead and go back to Google Classroom, find your exit ticket, complete the exit ticket, and submit. Once you have that finished, if you have time, you need to work on the guided practice book pages in your book, page 150 and 151.